Hello everyone. In this video, I'm going to go over the solutions to the CSCI-181 test 2 review questions. So just a reminder about how this test is going to work. This is a timed paper and pencil test with no computers. You are allowed to bring a cheat sheet, which is a 3-inch by 5-inch index card, double-sided. If you don't have an index card, you can just measure the same amount of paper and cut it out. You can write whatever you want on your card only by hand. And you can include things like Python syntax, example code, answers to these review questions, inspirational quotes, a sketch of your cat, or anything else that you want. So the real questions that will be on test 2 are going to be extremely similar to these, but the test will be about 1/3 this length. All right, so here we go. So the first part is code tracing with functions. So you'll be given some functions to look at that will be similar to these, and we'll assume that these are defined at the top of a Python program. So first you should look at these functions and try to see if you understand what they do. So the function f of n is a function that we can plug one argument into, and it looks like it's a numerical argument because we're using the percent operator. So n%3 is going to take the number that the user or the programmer plugs in, and it's going to calculate the remainder after division by 3. And then it's going to check whether that remainder is equal to 0, and it's going to return true if the remainder is 0, and it's going to return false if the remainder is not 0. Okay, so basically if the number that we plug in is a multiple of 3, then the remainder after division by 3 will be 0, and this will return true. Otherwise, it will return false. The second function is g. So we plug in two things called s and t to g. And again, it looks like they are numbers because we're squaring them down here. So what's going to happen with s and t is we square each of them, and then we add those squares together, and then we raise that sum to the power of 1/2. So raising to the power of 1/2 is the same as doing the square root. So it's basically like the distance formula. You square both numbers, you add them together, and then you take the square root. And lastly, we have the h function, which also has one argument. And again, it looks like the argument is supposed to be a number because we're dividing it by 3. So this is integer division by 3, which means it's going to do regular division by 3, but then it's going to round it down to the next integer that will be below whatever the answer is. If the answer was already an integer, then it won't do anything. It'll just keep that answer. But if the answer when dividing by 3 was not an integer, then it will round down to the next integer below. Okay, and then after doing that is going to multiply by 3. All right, so the question is, what is going to be printed if each line below is added to the end of the program? So your options are to write something out that will be printed, or to circle nothing, or to circle error. So I did the first one for you, g of 3, 4. So if we plug 3 and 4 in here for s and t, we're doing 3 squared, which is 9, plus 4 squared, which is 16. 9 plus 16 will give us 25. And then we're raising 25 to the 1/2, so square root of 25 is 5. And then just keep in mind that if you are raising anything to a fractional power like this, it is going to come out as a float. I probably won't take any points off for getting that wrong, but it would come out as a float, so it would be 0.0 instead of just 5. Next one, h of 11. So we are plugging in 11 for n in the h function here. So we're going to do 11 divided by 3. Now 11 divided by 3, I think should be between 2 and 3, since 9 is 3 times 3 and 12 is 4 times 3, and 11 is between 9 and 12. So 11 divided by 3 should be 3 point something. So this is then going to be rounded down to 3, and then that 3 is going to be multiplied by 3, so we're going to get 9. And it is going to just come out as an integer, because the double slash operation always returns an integer, and multiplying an integer by an integer will also give you an integer. The next one, if we plug in high to f, we're going to come up here to f. N is going to be high, the string high, and you cannot do percent operation with a string. So this one is going to give you an error. So let's see, how should I indicate this? Maybe I'll just highlight it. Okay, for the next one, first we're going to do the inside part. So the order of operations is the same as in math. It's things in parentheses first. So we're going to do this inner part h of 11 first. Well, actually, we already did that up here, right? So we already know that's going to be 9. So then h of 11 is going to be replaced with 9. And then Python is going to plug 9 into the f function. So when we plug 9 into f, we're putting 9 in here for n. So we're going to do 9% 3. So the remainder of after 9 is divided by 3 is going to be 0. So this part here that I have highlighted, 9% 3, will indeed be 0. And then Python is going to check, is that equal to 0? And it's going to be a yes, 0 does equal 0. So that will return true. And so here we will print out true. All right, next question. F of g of 3, 4. So we do have 3, 4 from previously up here. It's 5.0. So really all we need to do is plug in 5.0 to the f function. So we're coming up here, we're putting in 5.0 for for n in the f function. So we're doing 5% 3. And so the remainder of dividing 5 by 3, we're going to get a remainder of 2, because 3 goes into 5 once, and then there's a remainder of 2. So this part is going to be evaluated as 2, and 2 is not equal to 0. So this will return false. So we're going to have false here. All right. Next one, g of 0, comma, -1. So we're going to be putting in 0 for s and -1 for t. So 0 squared is 0. -1 squared is 1. So the sum of 0 and 1 here is 1. And then we are doing the square root of 1, which is 1. And it is going to come out as a float. I'm not going to take off points if you didn't realize that, though. I'm not sure we ever actually talked about the fact that if you raise anything or any number to a fractional or a decimal power, it will come out as a float. Okay, the next one is we are plugging in g of 0, -1 into the f function. So basically take the answer from the last line, and we're going to put that into the f function. So we're putting 1.0 into f for n. So n is going to be 1.0. So we're doing 1 divided by 3, and the remainder of that is going to be 1. So 3 goes into 1 0 times, so the 1 is the entire, the number that we're dividing, the 1 is the remainder. So 1 is not equal to 0, so this will be false. Okay, so this will be false. Oops, sorry, false. All right. And the next one, we are doing f of 2 and f of 3. We have to evaluate both of those and then plug them into the g function. Okay, so f of 2 is going to be, okay, so we're plugging in 2 here for n. So 2% 3. So we're doing 2 divided by 3, and then the remainder of that will be 2. Okay, so 3 goes into 2 0 times, so the 2 is the remainder. And that is not equal to 0. So this is going to return false. So when you think about what Python is doing here, Python is going to try to evaluate g of false. And then for f of 3, we are going to get true from that one. I think, did we do that one already? Oh, no, we didn't. So when I do f of 3, I put in 3 here for n. So 3% 3 is going to be 0, which is equal to 0. So it's going to be like this. So then we go to the g function. And what is going to happen when we try to square false or true? So I actually just paused the video to go to go check because I couldn't remember what happens when you try to square the values false or true. It should either give you an error or it treats false like it's 0 and true like it's 1. I couldn't remember which it was. So I did put this in, I put it into a Jupyter notebook. Here's the functions, I define them. So I ran that to define the functions, and then I ran these print lines here. So this is the last one, and it does actually give 1.0. So I think it basically treats false as if it were 0 and true as if it were 1. I had forgotten about that because some languages do that and some don't. I think this question is too hard for the test because we never really went over that in class about what happens if you try to put Boolean values into like arithmetic operations. So we would not put that on the test, but it does come out as 1.0, strangely enough. All right, so next question. Okay, so back to my Word document here. Part 2 is code tracing with while loops. So we're going to assume that each problem here is a different Python program, so they're not connected to each other. At the end of each line where a variable's value is assigned or updated, write down the value that the variable is assigned. For variables that get a new value, put a comma after the old value and then put the new value. Okay, so I put an example here in my own handwriting so you guys could see like kind of how I expect you to answer it. But I want to go over this one, I think, in my Jupyter notebook so I can show you guys how I got this example. So let me switch to that. Okay, so here is the same problem. And I'm going to pretend that I'm Python and I'm going to run this code. Okay, so starting at the very first line, a variable is assigned on this line. So n is assigned to be 100. So instead of using the little table like I had in the Word document, I'm going to write down these values in comments. So I'll put a hashtag before them. So n is assigned to be 100 in this line. So Python is remembering that n is 100. In the next line, m is assigned to be 76. And then in the next line, there is not a variable assignment on this line, but it might be nice to keep track of the true and false value of the condition anyway, so we can think about whether the loop is going to actually run. So on this line, we're checking whether m is greater than 0 or not. Python has to check whether m is greater than 0. So m is currently 76, which means m is greater than 0. So this would be evaluated as true, although Python is not storing that as a variable. Okay, since the while condition was true, we will go ahead and run the code that is in the loop. So on this line, temp is assigned to have the value of m, which is currently 76. Okay, so you have to be able to refer back to the previous variables. On the next line, m is assigned a new value. This one is a little bit trickier. You have to do a calculation. So m is going to be assigned n% m. So we need to look at what the current values are. So n is currently 100, and then we're going to do percent with the current m value. The current m value is 76. Okay, so this is the operation that Python is going to calculate. So 100 divided by 76, we want the remainder of that. So 76 goes into 100 one time, and then there is a remainder of 24. So m is going to be reassigned to be 24 after this line. And then on the last line here, n is going to be assigned whatever value is in temp, which currently is 76. Okay, and then pretending that we're Python, we're going to come back up to the top of the loop and check the while condition again. So is m greater than 0? So m is now 24. So yes, it is still greater than 0, so that is true. So now we're going to do this code again. So temp is going to be assigned the value of m. So temp is now going to become whatever m is, which is currently 24. Okay, now we're going to reassign m to be n% m. So we have to figure out what are the current values of n and m. So n is currently 76. M is currently, let's see, oh, it was last assigned on this line, so it's this one right here, 24. Okay, so now we need to calculate 76% 24. So 24, I think 24 times 3 is 72. So the remainder then is going to be 4. All right, so that is the new value of m. And on the last line here, n is going to be assigned the value of temp, which is currently 24 from up here. Okay, now we're going to come back up to the top of the loop and check again if the condition is true. Is m still greater than 0? So m is currently 4, so yes, it is. So we're going to do the loop code again. So temp will be assigned the value of m, which is currently 4. M is going to be assigned n% m. So n is currently 24, and m is currently 4. So 24% 4. So now 4 goes into 24 6 times, and there's no remainder. So m is now going to become 0. And the last line here, n is going to get the value of temp, which is currently 4. Now we come back up to the top of the loop, check the condition again. Is m greater than 0? And now finally we see it's not greater than 0. It became 0 right here. So now we finally stop and we don't do anything else. This is the end. Just if you're interested, this is called the Euclidean algorithm, and it calculates the greatest common denominator of these two numbers that you start with, which is indeed 4. Okay, so that was the example. And if you look back at the Word document, I had basically just written all that out in my own handwriting. So when you're taking the real test, you'll do this in your own handwriting next to each line. But for the solutions here, I will just type it in the Jupyter notebook, since that's a little bit easier for me. Okay, so problem A, x is assigned the value of 10. So that's the first thing that we're going to put on the line next to it. Y is assigned the value of x, so y is also going to become 10. And then n is assigned 0, so that's easy, just stays the same. Here, I'm not requiring you to write this part since it's not a variable assignment, and I didn't put that in the instructions, but you need to know whether it's true or false so you can see whether the code is going to run or not. All right, so we do need to check, is x greater than 1? X greater than 1, so currently x is 10, so you're checking is 10 greater than 1, and that is true. Okay, so we start off with true, which means we will run the code. So now y is assigned the value of y minus 1. So current value of y is 10. Okay, so Python is going to evaluate 10 minus 1, which is 9, and y is going to be assigned that value, the new value of 9. Okay, now we have to check whether this condition is true to know whether or not this code inside the if is going to run. Okay, so we need to check what is x% y, and is that equal to 0 or not. Okay, so currently x% y, I'm going to say that this equals, like in the sense of a Python expression, this literally equals. So current value of x is 10. And then current value of y is 9. Okay, so I'm doing 10% 9, and I'm checking if that equals 0. So right now I'm just simplifying this condition to evaluate it in the same way that Python would. So 9 goes into 10 one time, and it leaves a remainder of 1. So what I'm really checking here on this if condition is, does 1 equal 0? And the answer to that is no. So this is false. So the very first value for that if condition is false. Okay, so the code that is inside of the if is not going to run. So we skip these lines here. All right, so then we're going to come back up to the top of the while loop, and we're going to check, is x greater than 1? So currently x is still 10, so yeah, this is still true. All right, we come inside the loop, so we're going to do the loop again. Y gets the new value of, so it's going to be 1 less than it was before, so it's going to become 8. And now again, I'm going to check the if condition. So I want to check what is x% y. So 10%, and now y is 8. And I want to check if that equals 0. Okay, so 10% 8, 8 goes into 10 one time with a remainder of 2. And I want to check if that equals 0, and that is still false. Okay, you don't necessarily have to write out all of this work every single time, but at least on some scratch paper, you should be working it out. Do whatever math that you need to work out whether that condition is true or false. All right, so we're not going to carry out the code inside of the if. So we come back to the top of the loop. We're going to check this again. Well, x is still 10. Okay, so this is going to be true again. Y is going to become 1 less, 7. And hopefully you guys can see, like, once you do this a couple times, maybe it gets faster. So hopefully you can see this is still false. So now 10% 7 is 3. So we are checking, does 3 equal 0? And that is still false. Okay. So we're not going to do that code inside the if. We come back to the top of the loop. We check the condition again. Well, x is still 10. So this is still true. Y becomes 6. So we're just going to keep going like this until this if condition becomes true before anything else will happen. All right, so y is now 6, and we're going to check again. Is 10% 6 equal to 0? So we're really checking 10% 6 goes into 10 one time, remainder of 4. So we are checking if 4 equals 0, and that is still false. So we are not going to do the code inside the if. Skip it, come back up to the top of the loop, check the while condition. Is x still greater than 1? Yes, x is still 10. This is true. And now finally something different is going to happen, because now y becomes 5. And we're going to check this condition, x% y equal to 0. So finally, x is still 10, y is 5. And now when we do 10% 5, 5 goes into 10 twice with 0 remainder. And we are checking if this equals 0. So finally, we're checking if 0 equals 0, and we're getting it true. So for the very first time here, we are going to do the code that is inside the if. Come back all the way over to the left. So we will finally do this code here. X is going to become x /y. Okay, so x is currently 10 and y is currently 5. So we're doing 10 divided by 5, and then we are rounding to the nearest integer below. So 10 divided by 5 is already an integer. It is 2. So that's the value that x is going to get. So x's new value is 2. And then n is going to become 1 more than whatever it was before. So it's currently 0. So n is going to become 1. All right, now we go back up to the top of the loop and we check, is x greater than 1? X is currently 2, which is greater than 1, so this is true. Okay, we go down to the first line. Y is going to become 1 less than it was before, so y becomes 4. All right, and now we are checking if x% y is 0. So currently, x is 2, y is 4, and we are checking if that equals 0. So 4 does not go into 2 at all. So 2% 4 is just 2 again. It's all remainder. And we're checking if that equals 0. That is false. So we are not going to do the code inside the if. We come back to the top of the loop. We check, is x still greater than 1? Well, x is still 2, so yes. Now y becomes 3. Okay, so x is 2, y is 3. We are checking, is 2% 3 equal to 0? So 2% 3 is 2 again. It's all remainder. So we're checking if 2 equals 0. That is false. Okay, so we're not going to do the code inside the loop, or sorry, inside the if. We're going to come back to the top of the loop. We're going to check if x is still greater than 1. Yes, it is. It is still 2, so it's greater than 1. Now y becomes 1 less than before, so it's 2. All right, so now we're doing x% y. That's going to be 2% 2. And we're checking if that equals 0. So finally, we will have something happen again. So we're checking, does 2% 2 equal 0? And this time it does, because the remainder from dividing 2 by 2 is 0, and that does equal 0. So this is true. So we are going to carry out the code inside of the if. So now x will become x divided / by y. So x is 2, y is 2. So we're doing 2 / 2. So that is going to be 1, and it's already an integer, so we don't need to round down. All right, and now n is going to become 1 more than it was before. All right, so now we come back up to the top of the loop and we check, is x still greater than 1? And finally here we have false. So x is currently 1, which is not greater than 1, so we are able to stop. Okay, so that was a lot of times for the loop to run, but you know, it is what it is. It can happen. So this code, if anyone is curious, this code counts how many prime divisors of an integer there are. So 10 has 2 prime divisors, which are 5 and 2. And so, oops. So that's what the n number here is counting, is the number of prime divisors. All right, so the next one is problem B. So we're starting out with A is defined to be 1, and then B is assigned to be 2. And now we're checking whether B is less than 30. So is B less than 30? Currently B is 2, so that is going to start off with being true. So since it's true, we're going to go ahead and do the code in the loop. So temp is assigned the value of b, which is currently 2. B is assigned the value of a plus b. So a is currently 1, and b is currently 2. So b is going to be assigned the value 3. And now a is going to be assigned the value of temp, which is currently 2. Okay, now we come back up to the top and we check the condition again. Is b still is b still less than 30? So b is currently 3, which is less than 30. Since it's true, we do the code again. Temp becomes whatever b is, which is currently 3. Then b becomes a plus b. So currently a is 2, and b is, the last place it was assigned was actually right here. So b is currently 3. So b is going to become 5. Now a is assigned the value of temp, which is currently 3. Okay, and now we come back up to the top, check, is b still less than 30? Yes, it is. 5 is less than 30, true. So now we do the code again. Temp is assigned the value of b, which is currently 5. B is assigned the value of a plus b. So a is currently 3, b is currently 5. So b is assigned to be 8. Now a is assigned the value of temp, which is currently 5. Come back up to the top. Is b still less than 30? 8 is less than 30, so this is true. So we do the code again. Temp gets the value of b, which is 8. B gets a plus b, so a is currently 5, b is currently 8. So b's new value is 13. A is assigned the current value of temp, currently 8. Come back up to the top. Check, is b less than 30? Yes, 13 is less than 30, so this is true. So we do the code again. Temp gets the value of b, currently 13. B gets the value of current value of a is 8 plus current value of b is 13. So b is assigned 21. And now a gets the value of temp, which is 13. Come back up to the top, check, is b still less than 30? Yes, b is 21, so we do this again. Temp gets the value of b, which is currently 21. B gets the value of a plus b. A is currently 13. B is currently 21. So b gets the value of 34. And then a gets the value of temp, currently 21. Come back up to the top, check, is b less than 30? Now we finally get false. 34 is not less than 30, so this is where it stops. And if you're curious, this was calculating the terms of the Fibonacci sequence. Okay, problem C. So starting off with 4 numbers, this part is easy. They just get whatever it says they get. So A is assigned to be 50, D is assigned to be 15, R is assigned the same value as A, which is 50, Q is assigned to 0. And now we check the condition. So is R greater than or equal to D? So this is checking whether or not 50 is greater than or equal to 15. So currently this is true. So we're going to run this code. So the new value of R will be current value of R, which is 50, minus current value of D, which is 15. So R is going to become 35. Okay, and now Q is going to increase by 1. So Q is going to become 1, since it was 0 before. All right, we come back up to the top of the loop, check if the condition is still true. So now R is 35, and we are checking whether that's greater than or equal to 15. And that is still true. Maybe I'll just space these a little bit. I know it looks weird to have like an inequality literally equal to something else, but that is how it works in Python. Inequalities like this are evaluated as true or false. So that is still true. So we're going to do the code again. R is assigned to be R minus D. So current value of R is 35 minus current value of D, 15. So R is going to become 20. Okay. One more line here. Q gets 1 added to its value. So Q is going to become 2. Come back up to the top, check, is this condition still true? So now R is 20, and we're checking if that's greater than or equal to D, which is still 15. So that is true. So we're going to do this again. R is going to become current value of R minus current value of D. So this is going to be 5. Q gets 1 added to it. Come back up to the top. Check is current value of R greater than or equal to current value of D. So now finally this is false, so we stop. Okay, so moving on to part 3, code tracing with for loops and string indexing and slicing. So basically the same as before. I'll go through an example with you. So this example I also wrote out in my own handwriting in the Word document, but I'll do it again for you guys on the video here. Okay. All right, so first variable assignment is S is assigned to be the empty string. So I'm just going to write it with the 2 quotes like that. Now for the for loop here, unlike with the while loop, there is a variable assignment on this line. So letter is assigned to be the first thing that is in that string of susq. So letter is going to start out being the capital S. All right, and then we're going to check this if condition to see if it's true. So is it true that letter, which is S, is in A-E-I-O-U? This is not true. This is false. Okay, since it's false, we're going to skip the code inside the if, and instead we will do the code inside the else. So S is going to be assigned to be the current value of S, which is the empty string, plus the current value of letter. So current value of letter is capital S. So we are concatenating the empty string with the capital S. We get a capital S. So empty string doesn't add anything there. All right, now we come back up to the top of the loop, and letter gets the new value that is the next letter. Okay, so next is the U, and we're going to again check is U in A-E-I-O-U. You don't necessarily have to write it out like this. I'm just trying to make it really explicit what I'm doing here. So that is now true. Okay, so we are going to do the code inside the if. So S is going to become current value of S, which we had down here. So it's the capital S string plus the star string. Okay, so we're going to concatenate those two. So this is going to become S star. That is one string with those 2 characters inside of it. Now we come back up to the top of the loop, and letter is now going to become the little s. So I won't write it out every time, but hopefully you guys can see the condition on the if here now is false. So little s is not in the A-E-I-O-U string. Okay, so now the s variable, we're going to skip this if line here and do the else because we got a false. So now the variable s is going to be assigned to be whatever it was before, which was S star plus letter. So letter currently is little s. There's a lot of s's running around in this problem. It makes it fairly confusing. But like this s is a string, this s is a variable. So they're 2 different things. All right. Right, so we're going to concatenate and get capital S star, little s, so the string of those 3 characters. Come back up to the top of the loop. So the next value for letter is the Q. So we're going to check if that is in the A-E-I-O-U string. It is not in there. So we're going to do the else condition. All right, so the variable little s is going to become whatever it was before. So currently capital S star, little s, and then we're going to add letter to that. So currently letter is Q string. So we're gluing these 2 strings together. This is going to be S star, little s, Q, end of string. Okay, and now up to the top again, this will be the last time it runs. So the last value for letter is going to be U. And we check, is that U in A-E-I-O-U? And this time, yes, it is. So this is true. So we are going to run this line of code inside the if block. So the variable s will become whatever it was before. So currently it's this plus the string with the star. Okay, so gluing those together is going to be like this. Okay, so hopefully you can see what this code does. It just replaces all the vowels in a string with stars. So it kind of makes it look like it's an expletive. All right, so that was the example one. It looks a little bit messy in handwriting maybe, because you have to put some like quotes and that sort of thing, but that's okay. All right, so let's go ahead and do problem A. So again, we're starting off with the variable s being an empty string, and t is the string that has susq in it. And now I is going to be in range 5. So you're going to make sure you understand what in range 5 means. This means the same as saying for I in, instead of a range, it's the same as listing out the numbers starting with 0 and then ending right before 5. So it's the same as this. Okay, so the first value that I is going to take on is 0. Oh, I forgot to put the comments for these ones too. I mean, hopefully it's pretty obvious what happens on these two lines. They just get assigned what it says they're assigned. Okay, so I starts off as 0, and then S is going to be assigned to be, now this is a little bit tricky. So S is going to be assigned to be T of I, which is currently 0. So T of 0, and then plus, and then whatever S was before. So currently S is the empty string. It's a little bit complicated to evaluate here, but T of 0, so this is the index 0 character from T. So looking at T up here, the index 0 character is the first character, capital S. Okay, so what we're doing here is we're concatenating that capital S from T with the current value of variable S, which is the empty string. So we are just going to get capital S there. So little s, the variable little s, is assigned to be the capital S string. All right, we come back up to the top of the loop, and I gets the next value in that range, which is 1. Okay, and now the variable little s is assigned to be T of 1, so that's the current value of I, plus current value of S, which is this capital S string that we got on the last step. Okay, so the index 1 character from T is this one. So capital S was index 0, then the little u is index 1. So what we're doing here is we're concatenating the little u with the previous value for S, which was the capital S. So the result here is US, like that. Hopefully you can already see what's happening here, but let's go through the rest of it. So I is going to become 2, the next value in the range. Okay, and the new value for S is going to be T of 2 plus current value of S, which is the lowercase u uppercase s string. Okay, so the index 2 character from T is the little s in the middle. Okay, so we're concatenating little s with lowercase u uppercase s. So we are getting S, U, S with the capital S at the end. Okay, when we come back to the top of the loop, I gets the next value in the range, which is 3. Okay, so then S is going to become T of 3 plus current value of S, which is S, U, capital S. Okay, so the index 3 character from T is, so this is 0, and then 1, 2, and then 3, so it's the Q. All right, so we're doing the Q plus SU capital S. So this is going to be, now you can really see what's happening, right? QSUS. Nope, I spelled it wrong. QSUS, like that. Yeah, so this is basically just spelling out the susq string in reverse. So for the very last run, I becomes 4, so this will be the last time because we've come to the end of the range. And S is going to become T of 4 plus current value of S, which is QSUS. Okay, so T of 4 is the index 4 character from T, which is the little u at the end. So this is going to be little u plus QSUS. Oops, wait, no, where did I go wrong? Oh yeah, no, that was it. Okay, sorry. So this is just the complete backwards result here. So what this code did was spell out the T string backwards. Okay, so that's it for that one. For problem B, X starts off at 1, and n goes through the range 2, 7, 2. So here you need to make sure you understand what this range is. This is the same as doing, so the numbers here would start at 2, and then they're going to stop before 7. So it always starts at the first number, stops right before the second number, but then if there's a third number there, it goes up by that number. Okay, so the first number is 2, the second number is 4, and then 6, and then that's right before 7, so that's where it stops at. Okay, so the first value for n here is going to be 2, and then x is going to become whatever it was before, which is currently 1, times current value of n, which is 2. So this is going to be 2. Come back to the top of the loop. N gets the next value in the range, which is 4. So x is going to become current value of x, which is 2, times current value of n, which is 4. So that's 8. Come back to the top of the loop. N becomes the next value in the range, 6. X is going to become current value of x, which is 8, times current value of n, which is 6. So this would be 48. And that's it. So it's just multiplies together these three numbers, basically. That's what the code does. All right, last one in this section, C. This one's a little bit tricky too because it has string slicing again. So S starts off as an empty string. Okay, and I is going to go through, so I think this is the same range we saw before. This is the same as doing 0, 1, 2, 3, 4. So if you don't put a first number there, if you just put one number inside range, it'll start at 0 and it'll stop right before that number. So it'll stop at 4. Okay, so the first value for I is going to be 0. And then what's going to happen with S is a little bit tricky. So S is going to be assigned to be whatever the current value is. So currently it's the empty string plus, and now it's going to be, oh, you know what? I think I actually meant to do something different in this problem. Is this really what I wrote? Yeah, I guess this is really what I wrote. I think I meant to have like another T string or something kind of similar to part A. So we're going to slice into S, and we're going to take every character in S starting from index 0. Okay, so starting from index 0, and then since there's nothing after the colon, going all the way to the end. So starting at the 0 index character in S, well, there is no 0 index character in S. So basically this is just going to return another empty string. So S is going to become an empty string plus an empty string. So in conclusion, S is still an empty string. And I think that's what's going to happen on every single line here, like every loop. It's just going to be an empty string again because I never gave it any other characters to like reference to. So I is going to become 1 on the next pass. And then S is just going to again be whatever it was before, the empty string, plus the slice into S from 1 to the end. So starting at index 1 and going to the end. But since there is no index 1, it is just going to return an empty string again. So this is just going to happen every single time, basically. So I is going to become 2, S is going to be an empty string again, I is going to become 3, S is going to become an empty string again, I is going to become 4, S is still going to be an empty string. Okay, so we can finish that one quickly. That's it. I actually meant to do something more interesting, and I think I just forgot to like put another string in here. Oh well. Okay, so moving on to part 4. So 4, 5, and 6 are about writing your own code. So this is where it gets a bit tricky. Okay, so part 4 is writing functions. So you just need to write the function. You don't need to include any lines of code where you test the function, although I am going to test them just for the purposes of making this video. So the first one, we write a function called max that takes 2 parameters, a and b, which are both numbers. So already that is enough to write the first line. So def, name of the function, max, parentheses, name of the parameters, which is a and b, and then this line has to end with a colon. All right, so you can do all of that just from the name of the function and the names of the parameters. All right, now what the function is supposed to do is return the greater of the two numbers. So for example, max of 2, 3 would return 3, max of 0, 1, or sorry, 0, negative 1 would return 0, and max of 1, 1 would return 1. Okay, so we need to check whether A is greater than B or whether B is greater than A. So to figure out which one is greater, I can use an if. So I'm going to check if A is greater than B, then A would be the max. So I would want to return A. Otherwise, if that's not the case, then I would return B. Okay, now you might be wondering how to handle the case where they're equal. Well, that will actually happen on the else too. Okay, so if the first number is bigger, then the first number will be returned. Otherwise, if they're equal or if the second number is bigger, then the second number will be returned. Okay, so for example, if I plug in 1 and 1 for both of them, then 1 is not greater than 1, so that would be false. So we would do this else part here. And let's just go ahead and run it to make sure that it is working. So I'll try the examples that were given. Max of 2 and 3, yep, it's 3. Let's see, max of 0 and -1, 0, and max of 1 and 1. Should be 1. Yes. Okay, so the only part that you need to put on the test is just the function definition, so these lines. Great, next part, write a function called seconds that takes two parameters, hr and min. So def seconds, hr min, colon. Okay, so you can do all that part just from the first sentence. The parameter min represents some number of minutes, and hour represents some number of hours. The function should convert the hours and minutes to seconds and return the number of seconds. So for example, seconds 1 should return 3660. So this would be 1 hour. 1 hour is 3600 seconds, and then 1 minute is 60 seconds. So in total, it's 3660. And seconds 010 should return 600. So that will be 10 minutes. 10 minutes is 600 seconds. Okay, so there's a few ways to do this. You could convert each one separately and then add them together. So for example, we could have like hour underscore secs, so the number of seconds that are in the HR variable. So in 1 hour, there are 60 minutes, and each minute is 60 seconds. So that's how you get 3,600 seconds per hour. So you would just take however many hours were passed to the function, whatever HR is, multiply that by 60 for 60 minutes, and then 60 for 60 seconds in each minute. And then you could convert the number of minutes to seconds, like this. So take min, multiply that by 60 to convert it into seconds. Then you could add these together and return that. So that's one way to do it. You could do it like that, or another way you could do it, I'll just put a second solution here. You could literally just do it in, oops, I forgot my colon. You could just do it in one line like this, return 3,600 times hour plus 60 times minute, like that. That's also fine. All right, let's go on to part C. So write a function called pay that takes two parameters, rate and hours. The parameter rate represents the hourly pay of a worker, and hours represents how many hours they worked. So I can already write the first line. So this is going to be def pay, oops, pay, rate, hours. Okay. If the worker worked more than 40 hours, the rate of pay for the hours above 40 should be doubled. For example, if the worker's rate is $10 and they worked 45 hours, they should make $10 per hour for the first 40 hours and $20 per hour for the last 5 hours. So their pay would be $10 times 40 plus $20 times 5 for $500. The function should calculate the amount of pay and return it. For example, pay 1045 should return 500. Okay, so basically, if they worked more than 40 hours, you have to do something different. So the first thing I would check is that, like, did they work more than 40 hours? So if their hours are more than 40, we have to do that differently. Otherwise, if they worked 40 or less, well, if they worked 40 or less, then all we have to do is multiply their rate times their hours, right? So that part's pretty easy. Just return their rate times their hours. But if they work more than 40, it's a little more complicated. So, well, if they work more than 40, then I've got to pay them the regular rate for the first 40 hours, right? So maybe I'll call this like reg pay or something. So for their regular pay for the first 40 hours, I'm just going to multiply by the regular rate by 40 hours. And then for their overtime pay, I got to figure out how many hours they worked over 40 and multiply by double the rate. Okay, so how many hours they worked over 40, I can get that by just subtracting 40 from the hours they worked. And then I'm going to multiply that by double their rate, like that. Okay, and then I'm just going to return their regular pay plus their overtime pay. All right, so that's that one. Let's move on to part 5, writing while loops. So part A, write a program that asks the user to enter a number repeatedly and does not stop asking until the user enters 0. Okay, so there's a couple of ways to do this. You're going to ask the user for a number, right? So you have to use the input command. So enter a number, something like this. Now, I never actually said that you have to check whether they really entered a number or not. So we could just tell them to enter a number and then not actually check if they did it or not. You're going to want to store this under a variable, and the reason you have to save it as a variable is so you can check in the while loop whether they entered 0 or not. So you're going to do a while loop, and the condition is going to be whether they entered 0. So you want to keep asking them as long as they did not enter 0. So the condition for the while loop should be that they did not enter 0. Now, if you want to do it like this, this 0 is a number, right? So then we would need to convert this to either a float or an int. Another way to do it would be if you don't convert this to a float or an int, you could check whether their answer was equal to the string 0. That would also be a fine way to do it, but I think this is the more common way that we've done it in class, so I'll do it this way. Convert their answer to a float, and then check whether that number that they gave me was equal to 0. Okay, so as long as it's not equal to 0, I basically just want to keep asking them this question over and over again. So I'm just going to paste this in here. And so if we run this, it's going to ask me to enter a number. I'll try 1, try 3.5, and now I'll try entering 0, and it stops. Okay. Okay, so that was part A. Let's look at part B. Write a program that uses a while loop to print the numbers 7, 12, 17, 22, etc. up through 102. Okay, so you're going to want to have a variable that represents the current number, and that number is going to start at 7. Okay, so then I want to print the number, and I want to then basically add 5 to it to get to the next number here. So it starts at 7, and then 12, 17. So you're going up by 5s. So basically the thing that I want to do is keep adding 5 to x and then printing x again, and then keep adding 5 to x and then printing x again. But I want to control this behavior with a loop. So instead of writing out these lines over and over, I want to have a loop doing this. So the two things that need to be repeated are printing x and then adding 5 to it. Okay, so that's what I'm going to put inside the loop. I'm not sure about the condition yet, so let me think about that. I'll come back to it. I want to print x, and then I want to add 5 to x. Now, when should I stop? So 7, 12, 17, 22, up through 102. So I guess I need to keep going as long as x hasn't reached the end yet. So as long as x is not equal to 102. If it gets to 102, then I want to stop, right? But let me think about that for a second. So actually, I think if x is 102, then I want to print 102, right? So maybe what I want to do is I want to stop, I want to keep going while x is less than or equal to 102. I think that would work. So that would allow x to be 102, and then the loop will run print 102, then x would become 107, and I would come to the top again, and the loop would not run again. So x would finish with the value 107, but that would not actually print out. So if I go ahead and run this, yeah, that works. There's multiple ways to do this. I mean, another way that you could have done it would be like start x at, okay, so another way you could do it, let me do it down here with a different variable, like y equals 2. So start 1 before the first one that you want to print. And then while y is not equal to 102, you could switch the order like this. First add 5 to y, and then print y, like this. That would also work, I think. Yeah. So basically you never print the, on the first one here, I'm never printing the last value of x, which is 107. And on the second one, I'm never printing the first value of y, which is 2. So it all depends on what order you want to put those two lines inside of the loop. Okay, so next one, I'll just note that this is another solution. All right, so part C, write a program that uses a while loop to print the numbers 1, 2, 4, 8, 16, etc. up through 256. So the pattern here is that we are doubling the number each time. So I guess I'm going to have a variable, maybe I'll call it n this time. N is going to start at 1, and then I want to print n, and then I want to double n, so n should become 2 times n, and then I want to print n again. So this is the pattern that I want to happen. I'm doubling it, and then I'm printing it, and then I'm doubling it, and then I'm printing it. So the behavior that I want to repeat is this print and then double, print and then double, print and then double. So this is what's going to go inside of my loop. And I'll think about the condition in a second. But these are the 2 lines that I want to repeat. So when to stop? So I guess I should do this as long as I haven't gotten to the last number yet. So while n is, I'm going to do less than or equal to 256. If I do less than, then I think I'm never going to print 256. So I need to have n actually be 256 on the last time through the loop so that that can get printed out. And then n would become 512, but that would not be printed out. Okay, so let's run this, see if it works. Yep. All right, so there'd be another one to do this. There would be another way to do this similarly to the last one, but either way is fine. All right, the very last part, writing for loops with the accumulator pattern. So part A, write a program that asks the user to enter a positive integer and then uses a for loop to calculate the sum of all the integers 1, 2, 3, etc. up to and including the user's number. So for example, if the user enters 5, the program would calculate 1 plus 2 plus 3 plus 4 plus 5 equals 15. Okay, so first we need to ask the user for a number. So we'll do num equals int input enter n integer. Okay, something like this. So the user will enter an integer. Oh, I should say positive integer. Okay, and then we will convert the user's input into an integer, and then we will store that under the name num. So then what we want to do is we want to calculate the sum of 1, 2, 3, 4, all the way up to the user's number. Okay, so for this, we're going to need the accumulator pattern. So I'm going to call the sum by the name sum, and it needs to start off at 0. So you start off with nothing in the accumulator pattern. And then you loop through all of the things that you want to add up. So we're going to loop through 1, 2, 3, 4, all the way up to the user's number. And we are being asked to use a for loop, not a while loop. Okay, so we're going to do for, and then we need another variable here, let's say, I don't know, x in, and then we're going to do a range. So we want the range of numbers from 1, 2, 3, all the way up to the user's number. Okay, so it's going to start at 1, and it's going to stop at num, which means I need to put num plus 1 here, because remember, the range always stops right before that second number. Okay, so I'm going to go from 1 to num plus 1. And then what I'm going to do is I'm going to add that number to sum. So sum is going to become whatever it was before, plus the current value of x in that range. All right, so let's give this a try. If the user enters 5, we should get 15. Oops, I didn't print it out. I mean, you don't have to print it out as part of the question, but just to see if we did it right, I should print it out so I can see. Yes, I got 15. If I enter 1, I should get 1. Yeah, if I enter 2, I should get 1 plus 2 is 3. Okay, so it is indeed working. So you don't need this last line to actually get the right answer, but that's how you would check if you did it right or not. All right, next one, write a program that asks the user to enter a string and then counts how many lowercase e characters are in the string. Okay, so we're gonna ask the user to enter a string. I'll call their string S, I guess. So input, enter a string. All right, so I'm saving their input as S. I do not convert this to an integer or anything because I'm asking them to enter a string, not a number. Now I want to count how many lowercase e characters are in the string. What I need to do is go through the string one character at a time, look at each character in turn. So in order to do that, I'm going to do a for loop through the string. So I'm going to do for character in S. So I'm going to look at each character one by one in this S string that they've given me. All right, and then what I want to do is count whether it's an E or not. So I'm going to check whether that character is an E. So if the character is an E, so if it's equal to an E, then what do I want to do? Well, then in that case, I want to add 1 to my count. So right now I don't have a count. So to do the accumulator pattern, I need a variable for what I'm trying to add up or whatever I'm trying to count. So I'm going to start my count at 0, and every time I see an E character, I'm going to add 1 to the count. All right, and that's it. So let me put a print statement here after the loop just to check if it's actually working. So let's try entering, I don't know, 4 E's. Right, we got 4. Let's try it with my name. Has 1 E. Yep, 1. Something that doesn't have any E's, maybe? 0 E's. Yep, so it is working. All right, and very last question, part C. Write a program that asks the user to enter a string. So I know how to do that. Enter a string. All right, and then it builds a new string that is the same as the user string, except that a space is inserted after every character. For example, if the user enters hello, the program would build the string. So this is hello, but with just a space after every character, including at the end. Okay, so this is similar to the last question in the sense that we need to go through each character in the string and look at it one by one. So we're going to have the same for loop like this. We're going to go through their string that they gave us and look at each character one by one. But then the pattern of what we're doing is a little bit different. So instead of accumulating a count of how many E's there were, we want to accumulate a new string. So we want to start with a string that has nothing in it, and we want to little bit by little bit build up this new string. Okay, so when I'm looking at the H character in the original string, I want to add an H and a space to the new string. When I look at the E in the original string, I want to add an E and a space to the new string, and so on. Okay, so for my new string, I'm going to need a variable for that. So maybe I'll just call it new string. That's kind of obvious name, but so that's going to start off with nothing in it. It's an empty string. Okay, and then I'm going to go one by one through the characters in the string that the user gave me, and I'm going to build up my new string. So what I want to go into my new string is whatever character that I'm currently looking at. Oh, sorry. I need to start by adding this to whatever new string was before so that I keep accumulating things to the end of that string. So the thing that I want to add on to the end of my new string is the current character that I'm looking at in the user string and also a space. So you just do quote with a space character between like that. Right, and that is it. So let's try printing out new string just to test this. So now if I run it, let me try doing my name. Yep. Let me try doing, I don't know, a number. Yep, so just putting spaces between everything very nicely. All right, well, that is it for the solution to these review questions. Good luck studying for the test. Make sure you practice doing all of these without looking at the solutions or without listening to my solutions. Try doing them by yourself.